the difference between successive number is constant. All right, for example, 1, 2, 3, 4, 5, all the way n. So the difference between each successive, so this is A1, this is A2. So the difference between each successive is a constant. We're gonna call it D. We're gonna call it D, and then we're gonna derive a formula for this one. All right. So how can we derive a formula? We're gonna write A n is equal to, so this is A, A2, A3, all the way to A n. Okay. So now we're gonna create a formula. We're gonna write a formula. So A n is equal to, we're gonna write A1 plus n minus 1 plus n minus 1 times D. So the D is the difference between the first term and the second term. So this is the formula. Another problem: 4, 7, 10, and then 13. So this is A1, this is A2, this is A3, this is A4. Let's find A5. Let's use this formula to find A5. A5 is equal to, A1 is 4 plus n minus 1, so 5 minus 1, this is 4, and D. So how can I find D? D is the difference between two successive sequence. So A2 minus A1, which is 7 minus 4, which is 3. So 3. So A5 is equal to 4 plus 12. So A5 is equal to 16. Is there 16? So 4, 7, 10, 13, yeah, it is 16. It makes sense. So every successive one, the constant, which is D, D is 3. So 3. So 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, and 13 plus 3 is 16. Now I'm going to show you the linear relationship. So this is this is 1, 2, 3. This is A1. So this is 1, this is 2, this is 3, this is 4, this is 5, and we have up until 16. So let's do the next one. A6. A6 should be 19. So 5, 10, 15, and 20. All right. So 1 gives us 4. 1 gives us 4. 2 gives us 7. 3 gives us 10. 4 gives us 13. And 5 gives us 19. So you see a linear line. Rise over run. What is the rise over run? 3 over 1. Okay. So you can use y is equal to mx minus x1 plus y1 to derive an equation for a linear line, mx plus b. All right. So y is m. M is 3. So let's take the first one. First point is 1, 4. X minus 1 plus 4. So y is equal to 3x minus 3 plus 4. So y is equal to 3x plus 1. So y is equal to 3x plus 1. Let's see whether we can predict by this equation the next a equal to 6 term. So a equal to 6 term. So let's see. So let's use this formula. So f of x is equal to 3x plus 1. So f of 6 is equal to 3, 6 plus 1. So 18 plus 1. So it's 19. So this is 19, you see. Is an is equal to a1 plus n minus 1 times d. Okay. Now what is the arithmetic? This one is arithmetic sequence, and this is arithmetic series. Okay. So the arithmetic series is the sum of arithmetic sequence. Sum of arithmetic sequence. Sum of arithmetic sequence. What do I mean? You take 1 plus 2 plus 3 plus 4 plus n. Alright, now how can you do that? So the Gauss gave us this formula, n plus 1 over 2. Alright, so this is the sum of all natural numbers, and this is the formula for that. This is formula for this one. So this is geometric, this is arithmetic sequence, and this is arithmetic series. Alright, so what is the equation for arithmetic series? I'm gonna erase this. I'm gonna write a general equation for arithmetic series. There are actually two. I'm gonna write both. N over 2 a1 plus an, and the other one is an is equal to n over 2 2a plus n minus 1 d. Now this is connected to n plus 1 over 2. This is connected with this one, as you see that. But let's make this one obvious, look like this one. So you have n over 2 a plus n minus 1 times d, as you see that. So as you see over here, this is a1. So this is a1, or I'm gonna just call it a plus n minus 1 d. All right, so this is a plus n minus 1 times d. So I can replace this one by an. Why can't I? So n over 2 a plus this one is this one, an. And this is the special case right here. Now I'm going to show you an example. Let's say 5 plus 8. So 5 plus 8 plus 11 plus 38. So I want to add this using the arithmetic series. So let's first use this one. an is equal to n is 12 over 2, a is 5, plus an is 38. an is 38. So Sn is equal to 6. 38 plus 5 is 43. So 43, okay, 6. 258. So the sum of this one is 258. You can do the same thing over here. Let's use this formula. 12 over 2, 2 times 5 plus n is 12 minus 1 and d is 3. So 6, 10 plus 11 times 3, 33. So 6 times 43. So 6 times 43 is 258. So both way we get the same answer. So you get to see the example of arithmetic series. Now we're gonna do the geometric series and geometric sequence, and that's it. So now I'm gonna get to write both formula as I told you. So this is an is equal to, or Sn is equal to, you have n over 2 a1 plus an, and this is Sn is equal to n over 2 2a plus n minus 1 times d. Okay. All right, now I'm gonna do the geometric sequence. After first term found by multiply by a constant. What am I talking about? For an example, let's consider this example. So let's consider this example: 15, 45, 125. Okay, so this is A1, this is A2, this is A3, and A4 we don't know. So let's write down the formula that gives us A4. So geometric sequence, the formula is so A R n minus 1. So an is equal to AR n minus 1. 5. So this is A1, this is A2, this is A3. So a few things we have to find R. For arithmetic sequence we have to find D. And how did you find D? D was equal to A2 minus A1. Now we have to find R. How do we find R? A2 divided by A1. So our A2 is 45 divided by 15, which is 3. Now you're gonna write the equation AN is equal to ARN minus 1. Let's find A4. So A4 is equal to A. We have A is 15. R, we found R is 3. And we have to write this. So A4 is equal to 15, 3 raised to 3. So A4 is equal to 15, 27, which is, I believe, 405, but you check with your calculator, I don't know. So the next thing we're going to do is geometric series. So geometric series is just sum of geometric sequence. Okay. All right. So now how can we write the equation? There are two. One is finite, one is infinite. Plus, all right. So this one, let's use the finite one to solve this problem. So A, 1 minus r raised to n over 1 minus r. So what is our A? A is 128. 1 minus, what is our r? Let's find the r. See r? So r is equal to 64. So which is A2 and 128. So that's going to give you half. So I'm going to write half. Now, n. So r raised to n. So what is our n? So we want to find A4, A5, A6, A7, A8. Okay, so let's write A8 over here. So this is, we are using the finite, so it has to be finite. So 1 minus r. R is half. So 128 and 1 minus 100, 2 raised to 8 is 256 over half. So 128, 256 minus 1, 255 over half. So let's do it. 128 times 255 divided by 256 times 2 over 1. Okay? So 2 goes to 256 120 times. Really? 1? Yeah. And this is 128. So is this 255? Amazing. Is that 255? From 10, if you drop the tennis ball from 10 meter above the ground. So 10 meter above the ground. Okay? So what does it do? It bounces. So every time it bounces down and bounce up. Okay? So when it bounced, it lost some of the height. So it loses some of the height due to coefficient of restitution. For example, when I slide a marker, it loses it eventually slow down and stop is because friction. If I, on the other hand, drop it, see, it lost. Not because of friction, but because the coefficient of restitution. So the next one is 5 meter, and the other one is 5 meter, and the following one is 2.5 and 2.5, and the other one is 1.25 and then 1.25, and so on. Now, what do you want to find? We want to find the vertical distance, sum of vertical distance the tennis ball travel until it stops. It never stops though in a world, in a theoretical world, it never stops. So how can we do that? Let's write it down. So this one is 10 meter. This one is 5 plus 5. So let's write 10 first. 10 times half plus 10 times half. This one is 1. This one is 10 times half square plus 10 times half square. This one is 10 times half cube plus 10 times half cube, and so on until the infinity. Now what we see that we see 10 plus 10 20 half. We see 10 plus 10 20 half square. We see 10 plus 10 20 half cube. Okay, so we want to make this one, this is 1. We want to make this one 20. So if we put half, this is 1, this must be then 0, then we write 20, then this become 20, but we have 10, so I'm going to subtract 10, negative 10 plus. Now I have negative 10 plus 20 half 0 plus 20 half 1 plus 20 half 2 plus 20 half 3 plus 20 half n. Now I can write in geometric series minus 10 as k goes to 0 to infinity ark, which can be written as this one, a over, so minus 10 a over 1 minus r. Minus 10 doesn't come with the formula. Minus 10 comes from the outside. So a rk is equal to a over 1 minus r. Is because the proof that, which I will show you in the future, which that infinity plus 1 is equal to infinity, so they cancel out. So minus 10, a is, what is it? A is 20, 1 minus r is half. So minus 10, 20 over half. So minus 10, this is plus. So there is a plus sign over here. So there is a plus sign over here. There is a plus sign over here. So minus 10 plus 40, which is 30. So the tennis ball traveled in a vertical direction 30 meters. Okay, so hopefully you understand arithmetic sequence, arithmetic series, geometric sequence, geometric series. Thank you. I can do anything I want, right?
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.